Hello everyone, welcome back to ptet.chemistry channel. So in this second lecture tutorial video, I'll continue this lesson on constructing or on obtaining the chemical formula of ionic compound. So electrovalent compounds, that is another name for ionic compound. So Cambridge like to use alternative names, and electrovalent compound simply mean ionic compound. They consist of oppositely charged ions. So we know that in the previous topic on structure and bonding, we define ionic bond or electrovalent bond as the electrostatic force of attraction between the oppositely charged ions. These are very strong ionic bonds that require high temperature or large amount of energy to actually break the strong ionic bond. That's why ionic compounds are usually solid with very high melting and boiling point. So this compound form is neutral in terms of the charges. The charges are neutral, so be very careful. I actually don't like the way they have used their language here, because neutral has a different meaning, especially when we talk about acidic or basic compounds. The neutral here refer to the charges on the positive ion equal to the charges on the negative ions. This is also not technically correct because it depends on the total net positive charge versus the total net negative charge. Okay, so for example, when you have NaCl, you will have Na plus and a Cl minus, and you know that sodium has lost one electron. Chlorine atom has gained one electron, so the one electron loss goes to chlorine, which gain one electron. If you have one of these, you have a total of plus one, you have a total of minus one. Overall, they combine in a fixed ratio, they combine in a 1-to-1 ratio. That is a compound. The compound formula consists of one sodium and one chlorine. However, we know it's a giant ionic structure, and giant ionic structure is defined as a giant lattice with alternating cations and anions. Basically, the oppositely charged ions are alternating from each other as they get attracted towards each other in that pattern. Alright, so what is important, however, is to note that ionic compound contain ions. Ions are charged particle, but ionic compound contains or consists of oppositely charged ions. The cation, which are positive charged ion, form as a result of losing electron. Negative ions form as a result of gaining electrons. So these cations and anions, they will balance in such a fixed ratio that they form an ionic compound. Back in atomic structure, 2 topics ago, you can catch that topical playlist on atomic structure on my channel as well. So compound is defined as a substance made out of 2 or more elements chemically combined in a fixed ratio. This fixed ratio is something that we'll talk about in this lecture tutorial. It's about balancing the charges. The total net positive versus the total net negative must cancel out to give you a compound that has no charge at all. So essentially what it's saying is zinc ion. In the previous lecture tutorial, we have the table of ions are something you have to come to grip with, and you have to learn them based on the name, based on the charges. These things cannot be wrong at all. So there's a couple of methods you can do this. I'll show you. They have done using the wordy method. So they're saying that the plus 2, you need 2 of the minus 1. So you cannot change the charge on the chlorine because group 7 atom has 7 valence electron. They just like to gain 1 electron to go to a fully filled outer shell. So Cl minus is a fixed formula, but we can change the number. In a lot of textbook, in a lot of fundamental, early or beginning lessons for year 9 or 14 years old chemistry learners being introduced to chemical formulas, you bring down the charges. You bring down the charges on the ions. That's why you need to have the formula of the ion correctly. Bring down the charges on the ion. The next thing we do is we do a cross multiply. We do a cross multiply of the value. So the value will be 1, and the value, hang on, let me just move this up a little bit. If I move that up, so if I cross multiply that, I cross multiply the value. I do not cross multiply the ion. Be very careful. You never ever cross multiply the ion. The ions stay where they are. Bring down the charges, cross multiply the value. The value of minus 1 is just 1. The value of 2 plus 2 is 2. So what does this mean? This actually means What does this mean? This means 1 of the zinc 2 plus. And what does the 2 means? The 2 means there are 2 of the Cl minus. So what we'll do is Cl minus, Cl minus. By writing them out like this, you get to see that you need 1 Zn and you need 2 Cl minus in order to balance out the charge. What we do right, however, is just the final formula. They look really simple, ZnCl2, which is what they have gotten there. Alright, so different way of doing it. They've done the wordy form of trying to explain it in words. Of course, there are also the cross multiply method, which a lot of students don't really understand what they're doing. You cross multiply the number because this is to do with lowest common multiple of primary school mathematics called LCM. So we have lost 2 electrons to give the zinc 2 plus, so 2 electrons involved. We have gained 1 electrons to get the minus 1 charge, so there's 1 number there. 2 electron loss, 1 electron gain. At what point do they come together? The lowest common multiple basically is the answer to that issue. The LCM is 2. That is why you need 2 electrons being transferred altogether to bring the charges to balance out the plus and the minus. The zinc plus 2 or zinc 2 plus, to involve 2 electrons, you just need 1 of the zinc 2 plus. To involve 2 electrons, this is gain of 1 electrons to give you Cl minus. That's why you need 2 of them to give you Cl minus and Cl minus. Minus 1 give you minus 2 electrons involved altogether. That is why this LCM method is exactly the same as this cross multiply method, and you will see across other examples that I'll do in this lecture tutorial that a lot of the time it comes down to simplest whole number ratio, basically governed by this idea of lowest common multiple. By writing out these things, we can see how many of each unit we have, and therefore we can get the number. The number at the bottom, if I don't show it, it simply means there's 1 zinc. The number at the end refers for the atom, refer for the element just before it. So there are 2 chlorine and 1 zinc. That's the formula of zinc chloride. Moving on, so we have sodium sulfate. The ion present is Na+. Sulfate is a tricky one because it's a polyatomic. It has got more than 1 atom. This is one of those things that you really must know. Sulfate is a salt. The salt, you get it from acid. You get it from H2SO4, which is sulfuric acid. Sulfuric acid has 2H+, therefore it's SO4 2-. That is the formula of a sulfate anion. Some people don't like the FATE spelling. You can use the PHATE spelling if you want to. So bring down the charges. That's the first thing you do. Get the ion correctly based on the name. Bring down the charges. The charges of Na plus is +1. The charges on the sulfate is -2. The next thing you do is cross multiply the value, not the charges. Cross multiply the value. The value of -2 is 2, and then the value of +1 is 1. So what does this represent? This represent 2 Na plus, meaning Na plus, there are 2 of them, and 1 of the SO4 2-, such that you can get the formula of 2 Na, and then SO4 is basically the whole unit, just 1, because it's a cation. There are 2 of them, and then the SO4 in the bracket. If you want, you can simplify. You can simplify further to give you Na2SO4. All right. So in this next example, we have aluminium sulfate. Our ions, our positive ion present is Al3+ from group 3. Sulfate is a polyatomic ion. Something that you should know is a salt from sulfuric acid. So if you have a sulfate, it's a salt from sulfuric acid, which is H2SO4. So that's sulfuric acid that give you the SO4 2-. That's why sulfate anion is SO4 2-. If I bring down the charges, it's +3 from Al3+, it's -2 from SO4 2-. Remember, our objective is to try and balance out the charges on the cations and the anion. So the charge is a property of that particular ion. That thing cannot change per ion, but you can change the number of ions, and that is essentially what you do when you do the cross multiply thing. The +3 will involve a loss of 3 electrons. The -2 is a result of gaining 2 electrons. If you do lowest common multiple called LCM, the LCM of 2 and 3 is, well, 2 times 3, which is 6. You need a total of 6 electrons being transferred. Therefore, from plus 3, you need a 6. You need 2 times of it. So essentially, that is the same thing as when you drew the cross multiply thing. You need 2 of these because you need plus 3 and another plus 3, 2 of them, to bring up the charges to plus 6. Or it comes from bringing down the value on the cross multiply. You bring down the value, you cross multiply the value from the other cross multiplied pair, so it means 2 of these, and the value on this one is plus 3, so you move down the 3 to the other side. So what that actually means, is you will have SO4 2 minus, SO4 2 minus, SO4 2 minus. So you have 3 of them, 3 of these. Okay, you never cross multiply the ion, you cross multiply the number of the ions. Now you have 2 of the Al3 plus, which give you a total of plus 6, and you have a minus 2 minus 2 minus 2, which give you a total of minus 6. So overall the compound is uncharged, so it's Al2 bracket SO4. Because this is a polyatomic ion, you have 3 of them, so I need to put it in a bracket. Put it in the bracket, it means 3 of the SO4 2 minus. This one doesn't need a bracket because it's not a polyatomic ion. Alright, moving on to the next one, we have iron 2 sulfate. With a compound like this, where they mention it in a square, in a bracket, in Roman numeral, that refers to the charges on the cation. In this case, it's Fe2 plus, and the sulfate is SO4 2 minus. If I try to do the cross multiply method, I first bring down the charges, and then what happens is I will cross multiply the value. So the value of minus 2 move to the other side is just 2, and then the value of plus 2 move to the other side is just 2. It's not right to say you need 2 of these and 2 of these, because these are not simplest ratio. And because they are not the simplest ratio, you need to divide it further. So you can divide by 2 both sides. If you divide by 2 both sides, 2 over 2 is 1, 2 over 2 is 1. So now it makes sense because you need 1 of the iron 2 plus and 1 of the SO4 2 minus in the simplest ratio possible. And remember that compound consists of the different 2 or more different elements chemically combined together in a fixed ratio, and you want it in the simplest ratio possible. So it's FeSO4, 1 of the iron 2 plus, 1 of the SO4 2 minus. This is the formula for iron 2 sulfate. Without looking at iron 2, if you see this is SO4 2 minus, then you know you have 1 of these iron. This iron must be Fe2 plus to give you the overall compound that has no charge. From the name, get the formula. From the formula, get the name. One way or another, your brain needs to be doing the work as you get more familiar with the underlying chemistry. So there are chemical formula of simple covalent compounds here. So they say these are the symbol of this element, and you should know that bromine exists therefore as Br2. Same thing with chlorine as Cl2. Same thing with fluorine will be F2. Iodine will be I2. Nitrogen is N2. Oxygen is O2. Hydrogen is H2. Carbon is giant molecular. So the fact that it's giant molecular means that you do not have single molecule. If you don't have single molecule, you cannot have molecular formula, not single molecule. So this not single molecule refers to carbon there, which can be diamond or graphite there. Okay. As for phosphorus and sulfur, they are the trickier one. Phosphorus actually exists as P4 molecule. So in one single molecule, you have 4 phosphorus atom, and sulfur exists as S8. I'm just going to quickly draw phosphorus for you. So this is how phosphorus actually exists as in reality. So that thing at the back there, is actually a covalent bond as well, just as at the back. So altogether you have 6 times covalent bond in P4 molecule. How about S8? S8 is this wonderful looking W. So what I've done is, so 1, 2, 3, 4, 5, 6, 7, 8. There's the add sulfur there. I'm going to try and draw it again. I first draw the W in front, and then I connect the W at the back. All right, and then what they do is sulfur, 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 sulfur along each of the turning point, and there will be 8 sulfur. There are, how many covalent bonds is there? 1, 2, 3, 4, 5, 6, 7, 8. So there are 8 times covalent bonds in the molecule. So a lot of confusion when students don't know how to count covalent bond, where each phosphorus is bonded to 3 other phosphorus, and they still have a lone pair on the phosphorus. Because phosphorus is in group 5, it's got 5 outer shell electrons, whereas sulfur is in group 6. When they use 2 to form covalent bond, you still have 2 more on each sulfur. Okay, so that thing is very, very straightforward. That is just counting your dot and cross from your last topic on chemical structure and bonding. Now the next bit is on working out the formula of covalent compound. Covalent compound is not ions, but you got to work it out in terms of the valency. We talk about this when we talk about structure and bonding. Carbon form 4 covalent bond. Carbon form 4 covalent bond, hydrogen form single covalent bond. When you count them, carbon form 1, 2, 3, 4, each hydrogen bond to 1, you get the formula of CH4. As for the next one, H2S, well, how you get H2S? Sulfur is below oxygen, is group 6, so they form 2 covalent bond. You have hydrogen and hydrogen. Sulfur can form 2 covalent bond, but it cannot be this because hydrogen only forms single covalent bond, so it has to be this. But then sulfur form 2 covalent bond, so there's 2 there, and you will get cross, 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 because group 6 uses 2 out of 6 valence electron to form covalent bond. You get H2S because in this single molecule, 2 hydrogen atom and 1 sulfur atom give you H2S molecule. Now I have here a lot of practice examples, so what I'll do is I will insert a page or insert a blank page, and I'll probably be going into that blank pages as I work through some of these examples as I run out of space, okay? So do try and pause the video and practice this as you go along. If you're not very good with formula, you need to be accustomed and really know the table of the formula of common ions given from the name, and you should know that table which I covered in the previous lecture tutorial, the lectorial part 1. Okay, and you will have these from your textbook, from your lesson notes, something that you need to be able to get before you can do calculations, such as the one from a practical or the one that will come beyond these formulas and balance equation and stuff. Okay, so I'm going to start with copper 2 oxide. So copper 2 oxide, so I'll have copper 2 plus O2 minus, copper 2 plus from copper 2, oxide from the oxygen, group 6, O2 minus. Bring down the charges, plus 2 and minus 2. Some people can see this straight away. Plus 2 balance out minus 2 exactly in a 1-to-1. So you just need one of these and one of these, and you can get CuO. Some people cannot see it straight away. Then you can always rely on good old mathematics, a formulaic approach where you cross multiply the value of the charges to the other side. This is plus 2, the value is 2, but it cross multiply to the other side. This is minus 2, the value is 2, you cross multiply to this side. I said just now, one of these has plus 2, one of these has minus 2. The charges cancel out, you only have 1-to-1. This is 2:2 because that is not the simplest ratio. That is not the simplest ratio, and that is usually not how you do formula. So what you do is you divide by 2 both sides, and what you will get is you get 1 and 1. So what does that mean? That means 1 of copper 2 plus, that means 1 of O2 minus. Therefore, the formula of copper 2 oxide is CuO. Alright, so I'm just going to move these working down here. Okay, and the formula will be copper 2 oxide CuO. Now, as I go through zinc nitrate, zinc 2 plus for the zinc ion, NO3 minus is a nitrate, NO3 minus. You cannot get the formula of polyatomic ions wrong. Bring down the charges. So these are ionic compound. Nitrate, nitrate is a salt from nitric acid. Nitric acid is HNO3. You've got to know the formula of your common acid. Now what I do is I cross multiply the value. The value is just 1 from the NO3 minus charge. The value is 1. The charge is minus 1. I cross multiply the value. Now the plus 2, the value is just 2. What does this mean? This means there's only one of the ion. You never cross multiply the ion, you cross multiply the value of the charges on the ion, such that this is a number, this is not a charge. It means one of these zinc 2 plus and the 2 of the NO3 minus means I can write 2 times like this. So hopefully you can see, well, I hope you can see there will be one zinc. Put a bracket because there will be 2 of the NO3 minus. There will be 2 of these. That's why we need a bracket like this. That's why the formula of zinc nitrate is ZnNO3 twice. Alright, this is pronounced as Zn bracket NO3 twice. Twice because there are 2 of them. Again, I'm gonna move that working down here. If you got any questions regarding any of these, feel free to just find me and ask me. Okay, this is a phosphate. Phosphate is a salt. Is a salt from acid. This acid is called phosphoric acid, and the formula is H3PO4. Okay, so which means the magnesium ion from group 2, it has a charge of Mg2 plus as an ion, and then you have PO4 3 minus. This is the phosphate anion. Do not get your anion and the charges wrong and the number of oxygen wrong. Okay, this is a plus 2 and a minus 3. Cross multiply the value on the charge. The value on the charge is 3. You never ever cross multiply the ion. You cross multiply the value on the charges because that is lowest common multiple that you are doing actually. Alright, what does the 3 means here? It means I have Mg2 plus, excuse me. It means I have 3 of Mg2 plus, so I'll try and write 3 of them so that you can see exactly what is going on. It's a number, that's why I keep on saying it's not a charge. And I have 2 of the PO4 3 minus. Hope you can see that the plus 2 plus 2 plus 2 give you plus 6. Minus 3 and minus 3 give you minus 6. Plus 6 minus 6, the overall compound has no charge. Now there is 3 magnesium 2 plus, and then put in a bracket, there are 2 of the PO4 3 minus. As you could see, that's what this number represents. When you do this cross multiply, that is essentially what you are doing. Okay, so Mg3PO4 twice. I just pass it here. So Mg3PO4 twice. There's Mg3PO4 twice. Sodium hydroxide, this is a really common base. You have heard of me talking about base or alkali when I talk about the general, actually the general word equations are coming out very soon after this topic actually. So you will come across this term called hydroxide, which are bases that contain hydroxide ion. They are OH minus. Now you have Na plus and OH minus for the hydroxide. Hope you can see plus 1 and minus 1. Even when you cross multiply them, it's just 1 and 1 for the value, which means 1 Na plus, 1 OH minus. Your formula is going to be NaOH. I'm just going to jump straight to the next one before I move them to the other page. You have calcium hydroxide for the one below sodium hydroxide. Calcium is from group 2, Ca2 plus, OH minus is still your good old hydroxide. Plus 2 for the charge on calcium 2 plus, minus 1 for the charge on OH minus. You cross multiply the value. The value of the charges on OH minus, the value of minus 1 is 1, so there's 1 here. The value of plus 2 is 2, so these are numbers, these are not charges. What does this mean? This means I need 1 calcium 2 plus, I need 2 OH minus. And as you could see, the plus 2 charge from one of these cancel out the minus 1 and minus 1, total of minus 2 for the anion, such that your formula will be 1 calcium and 2 hydroxide. 1 calcium 2 plus and 2 OH minus, CaOH twice. That's the formula of calcium hydroxide. Okay, I'm just going to cut this and put it to the other page. and then I'll cut the calcium hydroxide as well. So since I already explained how they work, you can always rewind the video and go back to the explanation about how they all work. All right, so NaOH, NaOH, and then that one is calcium hydroxide. The next one is pretty much the same thing, iron 3 hydroxide. I hope you can get FeOH 3 times. I'm just going to show it very quickly. Plus 3 minus 1. So I'm slowly increasing in pace. As you do these things, you need to get faster and faster. So this is Fe3 plus, and then there's 3 OH minus, such that you get FeOH 3 times. All right. Zinc hydroxide. Zinc hydroxide is zinc 2 plus and OH minus. Zinc is not from group 1 or group 2 or group 3. It's from transition metal, the block in the middle of the periodic table towards the end. So zinc 2 plus is a formula of the ion that you need to know from that table, which I talked about in the last lecture tutorial. So this is a plus 2 and a minus 1. You cross multiply the value on the charges. So that means you need 1 zinc 2 plus and 2 OH minus. So that the formula is zinc OH twice. Okay, I'm gonna copy this and cut it onto the other page so that will save me a lot of space there. But you could always come back to this and revisit this if you needed to. Okay, there's 4, 5, 6, 7, and 8, and 9. Okay. Let me go through the other thing a little bit faster now. So potassium is a group 1, so it's K plus. Chloride is from group 7, Cl minus. Hope you can see the plus 1 and the minus 1. They will cancel each other out. The formula will be KCl. When you have lead 2 chloride, lead is from group 4, okay, Pb, group 4, IV. So lead can be lead 2 or lead 4, as I mentioned in the last lecture tutorial. So you have Pb2 plus here, and you have Cl minus. Plus 2 minus 1, cross multiply the value on the charges. So minus 1, the value is 1, the value of plus 2 is 2. So that means you need 1 Pb2 plus, and you need 2 Cl minus. You have PbCl2. So that's the formula there. And I'm just going to move these to one side first, and then I'll copy them down later on. Silver nitrate, they don't mention it silver 1 here, but silver as a compound is always silver 1, so that is always referring to silver 1 or silver plus. So I'll have Ag plus NO3 minus because it's nitrate, plus 1 minus 1. Hopefully you can see the charges cancel each other out nicely. So one of each, then you will get AgNO3. Okay. Now I can copy this down to the empty page at the bottom there, and that will save me a lot more space. So that goes there, and this one can go here. Okay. So silver is also in the transition metal block, which is the middle of the periodic table. So you need to be careful. Sodium carbonate, sodium group 1, carbonate. This is the first time we've seen this anion, well, at least in this lecture tutorial, but I mentioned it in the table. Carbonate, sulfate, nitrate, phosphate, all these are polyatomic ion, many atom ion. Bring down the charges and then cross multiply the value on the charges, not the charges that got cross multiplied, but the value is 2, so I put down 2. I don't put down minus 2, I put down the value, the number. Okay, because these are charges that belong to the ion. These are numbers, it tells you how many of the ions you need. If you have 2 there, what does that mean? That means you need Na plus, you have 2, you need 2 of the Na plus. You have 1 there, what does it mean? 1 of the CO3, 2 minus. The charges balance out. For the compound have no charge. Plus 1 is a total of plus 2. Cancel out minus 2 from one of these. Then what you write is there are 2 Na and there's 1 CO3, which I don't need to put in a bracket. I don't need to put in a bracket because it's just one lot of it. Sodium carbonate, Na2CO3. Okay. The next one is sodium oxide, Na plus or 2 minus, plus 1 minus 2. You can hopefully get the hang of it now. You cross multiply the value, or you can think about balancing the charges. So you need Na plus, and O2 minus. hope you can see is Na2O, because you need 2 of the Na and you need 1 of the oxygen. Now I really need to move these down there, otherwise I really run out of space again. So a lot of the time these are not essential working, but if you are not very good with formula, you need to keep on doing this until you are very good at doing this, because otherwise you cannot get better at this without practicing. And one day when you become more and more of an expert and you can see the charges cancelling out, hopefully that will help you more. Okay, I'm talking about magnesium oxide, so this is not for this one, it's for this one here. Mg2 plus O2 minus, plus 2 minus 2, I hope you can see it's just MgO, because the ratio is going to be 2 bring down, 2 bring down, 2 is to 2 give you 1 is to 1. So I'm not going to do that. The Al3 plus and O2 minus, group 3 and group 6, the non-metal form anions, the metal form the cations. Plus 3 is the charge, minus 2 is the charge. You cross multiply the value is 2. You cross multiply, you move to the other side the value. These are number, these are value. These are charges that belong to the cations and anions. You do not ever cross multiply the ion, you cross multiply the value, because there's LCM. So that means you need 2 of the plus 3 and you need 3 of the minus 2. So you need Al3 plus, Al3 plus, and you need O2 minus, O2 minus, O2 minus, such that your formula is going to become Al2O3, that is aluminium oxide. So these common formulas, they should really become part of your vocabulary, because they are important case studies that you will have to do later on in other topics, including electrolysis, as well as chemistry of metals, that kind of stuff. All right. Silicon 4 oxide, this is from your structure and bonding. This is giant molecular structure. So it's got silicon, oxygen like this, silicon bonded to 4 oxygen, and then oxygen is bonded to 2 silicon, oxygen is bonded to 2 silicon, and each silicon is bonded to 4 oxygen again, like that. So SiO2 is the formula, and they are your case study. These are your case study from structure and bonding. You can never ever forget them. It's not ionic, it is giant molecular structure. There are no free ions at all. So I'll probably stop here for this part of the lecture tutorial. You can try the rest of the problem yourself, and I'll probably continue this in the next lecture tutorial. So thank you for watching. Follow me at ptet.chemistry on Instagram, Facebook, and Twitter if you use social media platforms. Yeah, just to stay connected or get connected, and subscribe to the channel and share the channel widely with friends, chat and study groups, juniors and seniors from school, and whoever else you think the channel might be useful for, including relative and whoever else really. Okay, so thank you for watching. See you in the next lecture tutorial. All right.